Sounds like a Giga counter, but it is actually a scintillation counter. It has a cesium iodide crystal in here in a photomultiplier tube, a power supply for the photomultiplier tube because it needs a lot of different voltages, and it has a microcontroller for counting. It has a amplifier right here, and yeah, this is the power supply. Let's check it with smoke alarm. The smoke alarms have this device contains 0.9 microcurries of americium 241, so like about 33,000 becquerels for our Europeans. Okay, let's put it on. Oh, look at that. It's actually quite radioactive. And not only does this circuit measure, not only does it detect radiation and reflects to it, it also measures the spectrum of the radiation. Depending on the energy of the gamma rays that hit the crystals in there, it produces varying levels of light output. And the photomultiplier tube multiplies that light output, then it gets processed here and here, and it counts separately for each different energy levels that it encounters. So let's see. Yeah. Here we see the gamma ray spectrum of americium 241. You see one big peak that should be around like 60 kilo-electron volts, and this one is around 23 kilo-electron volts. Nothing really is calibrated here, but again, if you want, you can rescale based on the numbers of here. Right, which is some noise detected by the counter, and some background radiation on the higher energies. So yeah, here you have it. Gamma spectrometer. Okay, I think it's some more to reflect. Yeah, I put this tape right where the radioactive sources inside the smoke alarm, and yeah, I don't want to take that apart. Okay. This a large resistance resistor that I have for verifying the voltage here. That's a Crocktoff-Walton, how do you pronounce it? Anyway, voltage multiplier, and it gives us voltages. This particular tube needs minus 50 volts here, minus 150, 250, 350, and so on all the way to minus 850 here, right? Even though the voltage might sound scary, but the current is very, very low, and the capacitance is actually pretty small. So there's only like 1 or 2 micro or millijoules of energy into the capacitor, so it should be pretty harmless. Except if you say if you were winning in it, touching it and touching something else there, you could burn out a microcontroller or something that should barely shock you, right? And this is the steel length, it's just for programming the microcontroller, this USB connection, sending data back. This is used to try to stabilize the 3.3 volt rail because unfortunately it has no external voltage reference. Everything is referenced to the supply voltage. It's actually kind of stupid. Anyway, this thing puts out a lot of electromagnetic noise, but it's driven by the microcontroller, and it is synchronized to the data capture, so it simply excludes the data around the times when this is switched. So that works quite nicely for noise minimization. It works a lot better than you would think, right? Yeah. Have some other sources. I have like a Fiestaware plate that I borrowed from my mother-in-law. I might post another video with it. Yeah.